Alright, today I'll be going over LeetCode problem 21, merge two sorted lists. In this problem, we're given the heads of two sorted linked lists, and we must merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists, and in the end, we'll return the head of the merged linked list. So, to summarize, a merged sorted linked list will have the nodes in ascending order from least to greatest. Now, to get into the code of how I implemented this, we can see that I used a while loop with a series of if and else statements. The first thing I did was instantiate a new head of the linked list with an empty node and created a cur pointer that points to the head of that new linked list, which is empty so far. Now, utilizing a while loop, within the while loop, we see list 1 is not null and list 2 is not null. This is essentially going to iterate through both lists until one of the lists is fully traversed. Now, at the if statement list1.val less than list2.val, we're trying to check if the first value in list 1 is less than the value in list 2. If that's the case, our cur pointer .next is going to point to the list 1 as it's the smallest value so far. And then we're going to iterate through list 1 by doing list1.next. Otherwise, if list 2 has the smallest value, cur is going to point to list 2, and then we're going to iterate through list 2 with list2.next. After we end the series of comparing the smallest nodes, we're going to update the cur pointer by doing cur equals cur.next. Now, once we reach the end of one of the list nodes, at least one of them, the code below here is going to run where if list 1 is not null, we know that it still has nodes to traverse through, and since it's already in sorted order, we can just add the nodes one at a time without worrying about comparisons. And we would do that by doing cur.next equals list1, and then finish iterating through list 1 until it's null by doing list1.next. And if list 2 is the one that still has nodes to traverse through, we also know that it's already in sorted order, thus we can do the same process here. And at the end, we're going to return head.next. It's important to note that we are not returning just head, because when we instantiated the head node, we instantiated it with an empty list node. Thus, we have to return head.next, as head.next represents the true start of the merged linked list. And for the time complexity, it is O of n linear because we have to iterate through the entirety of both lists, where n is the number of nodes in both lists. And as n increases, the runtime is going to increase in linear fashion.